Hello, I'm Greg. I work as a software architect / senior developer for a company in the UK that is dealing with resumes, processing the resumes and searching candidates. I also do freelance stuff, so if any of you need some help with putting the applications into Docker containers, you can contact me. So first of all, the complicated. It's like a big word. It can mean multiple things. I will explain to you what we thought it was a complicated application and how it got even more complex. So we started with PHP and Perl application. Some of the work was done in PHP, some of the work was done in Perl. Behind Nginx, there was a web and back office. We use Solr, MySQL, S3, and Redis. So pretty standard, except for the PHP and Perl. So the half of the application was in PHP, half was in Perl, with some custom extensions for both PHP and Perl. For Solr, for example, new developer that was starting working had to spend whole day preparing the environment, downloading all the stuff, and there's one walkthrough for Debian, second one for Ubuntu, second one for the Red Hat. For other systems, Windows is a separate thing because web developers use Photoshop and Windows for accessing the web applications. So it was complex in terms of many multiple elements, but the application itself wasn't that complex. But in time, there was more. We ditched Perl, switched entirely to PHP, but there was a partner API, there was a background processing. We created our own internal API that was using Solr and Elasticsearch. We were using Cassandra, MySQL, SQS, S3, and Redis. So the number of elements is growing, and preparing everything for deployment either on a staging server or a developer machine, it was taking more and more time. That's why we developed a plan to solve that issue. And we were requiring speed of deployment, ease of use, ability to repeat the environment multiple times, ability to move everything, to version stuff. So environment is matching the application version. If we develop something new and environment changes, it also matches the application version, and we can switch back and forth. And security. So enter Docker. Show of hands, who's using Docker in any capacity? Oh, so you probably already know all of that. Docker is a response for the standard question that it works. It just works. But Docker has a lot of features, and we as a company, we are using only this part of it. So it's not all, it's not meant to be a guide for answer for every question. This is only our perspective. Besides Docker, we are using Vagrant and Thing for the whole environment. And if you are interested, I have a second presentation tomorrow, more about Vagrant and Thing and Docker. In the bigger room with more people, no pressure. I heard this question a lot, why do we use Vagrant instead of Docker Compose? Because when we started, the Vagrant was more popular, so we started using it. It's scripted. This is very important because Docker Compose is just a file. You cannot do anything in it. It just lists your stuff. To process it or prepare it, you would have to write something from scratch. And Vagrant File is a Ruby script, so you can code in it. And it's better on Windows because it manages the VirtualBox VM, and this is important for the front-end stuff for the people that are working on Windows and Photoshop. So how do we work? To start environment, it's only one command. Before that, it was the whole day shuffling multiple commands, downloading multiple packages. It was a mess, so this is quite an improvement. We have a Docker file for every project that extends the base image. We run all those images on the developer machine. We mount the code from the host system. So developer is working on a code and F5 and he sees the change. In front of it, there's one container with Nginx. And the developer, when there's a change in the environment, he pushes the Docker file only, or the Vagrant file, or Nginx config, or whatever, only this to the repository. So the Docker image is not committed. There's a Xdebug extension there, there's XHFProf there, and some other tools. So this is like the only difference is we mount additional catalog and we include one additional config file on the developer machine. Then Jenkins orchestrates our deployments on the staging and testing servers. So it gets the request using the webhooks. He downloads the code from the Git with the Docker file. Image is created, container is launched, Nginx is restarted on the staging server. The unit tests are running inside the container with the same version of PHP and all the extensions that we use on production. Integration test, functional test, acceptance test, everything is running on this one container. And the container is mounted and visible and running on the internal network under the name like branch something something. So if we need to show the code to someone, we just deploy it to staging, send a link to for example, the business or to front end to show the error or something. So it's running on staging server. Then for the master, there is an additional step. When we start to integrate for the next version, we take the container with the master branch, exactly the same as before, the one before, and we push it to the repository. We use the Amazon repository for the Elastic Container service. And after this point, the image itself is not changed in any way. So it's running one more on one more service, on one more layer, the acceptance test before the new version is released, and the same image is then pulled on the production. So on every server, we do pull of the image. We remove the server from load balancer. We run the new version, and we add server to the load balancer. Pretty simple stuff. The background processing, we do have a lot of scripts that are running using either cron or supervisor, but the code is prepared to run on small chunks of data. So it fetches something from SQS or database or some event from Cassandra. He processes it and then dies. That's why when we replace the image on the local, when we do Docker pull, and the new image is downloaded, the next iteration of the cron jobs or supervisor or whatever, it will run on the new code. Docker is not only for Linux. We can use it for both, on Windows for both native applications. So exactly the same as on Linux. We just deploy it. And in the recent versions, I haven't tested it myself, and we didn't migrate it yet from Vagrant with Linux. So you can use something that's called Linux. Oh, sorry, there's a typo there. Linux container on Windows. It's like a microkernel with one process running. So it's more like a running of Linux binary on the Windows host, and you can run on the same Docker daemon. You can run both Linux binaries and Windows, but it's not production ready yet. So it requires running Hyper-V, so only Windows Professional and Windows Server. The home version is not included there. And when the Hyper-V is enabled, it will disable the VirtualBox, so it cannot run at the same time. I haven't tested it, but you can run Apache on the same binary as on Linux on Windows machine, and it works, supposedly. The things that are not working, the Docker Swarm is not supported at all. The networking is not as good as on Linux. So, for example, the ports are not shared on the localhost alias. You need to have a container IP to get it. You need to run something like that, something like this, get the IP, and then use it on the in the URL of the browser. And IO notify does not work. So Node.js will not work on the container on Windows. So that was the short information about how we do it and what we do. Now the stuff that we learned the hard way. So we don't use Docker for everything. We do have databases. We do have Solr. We do have Elasticsearch, SQS, S3, and everything. We tried to run it self-contained on a laptop, but our database is 100 gigabytes. So every time importing that stuff from somewhere would defy the purpose of easily switchable versions of the code. So if your application is small enough, like 1 gigabyte, 10 gigabytes, and the import can take 5 minutes, you can live with that. But in our case, we just have on the staging server, we have a developer database. If there are some new columns or some new tables, we try to make it backward compatible. If not, there is a second instance created, and then developer works on this. Copying databases in RDS on Amazon is pretty quick, so you can just move it and create new stuff there. In case you try to run it in the Docker container on the local machine on developer workstation, there's an issue with synchronization of the changes. So you have to either run it every time from the scratch, like get the structure SQL file from the repository and create it from the scratch every time, or you would have to, or you will have an issue with structure changes, new columns. Someone goes away on a vacation for 2 weeks, then he comes back and the application doesn't work because someone removed some column. And so we decided that for data storage, so MySQL, Solr, and Elasticsearch, those are the services that we use for the common one. So we have it on the staging server. Because for the NoSQL databases or storage document storage services, the issue is the same. Importing would have to be from the scratch every time. How do we maintain the multiple containers between each other? So Docker has a great thing that it's called link, and you can connect Docker container, for example, database instance that's exposing port, and when you run it, it will create an environment variable that is available on other containers. And in this variable, you will have a string that is like TCP : IP and port, different than this one. But this will be a port that you can connect MySQL from other container. And the great part of it is that environment variable you can reuse and just set it to the same value, for example, on production. So in our config files, we use only this kind of string to store the values. So on the developer workstation, the link command will do everything for us. On staging, when we have MySQL database also in the container, it will do it. Or if we have a separate instance on production or on staging, we can just provide environment variable with the value that we want to use. So it's you don't have to have a separate environment for developer, separate environment for production. You just use the environment variables and it just works. If you have multiple Dockers, like multiple staging servers, and you want to do some operation on all of them, like a cleaning, removing of the old images, you can connect to Docker using socket. So SSH, create a socket in this directory that will point to this file on the remote machine, use the credentials, and in the second terminal, because this will have to stay connected, on the second terminal, you expose this environment variable with the same file, and every operation on this machine, on this terminal, is done on a remote server. So in our case, we have a multiple staging servers, and once a week, we just iterate over them, connect to everyone, and remove, for example, old images. I think this is the key lesson that we learned. Better the Docker files, less problems there is with the environment. And what I mean by that is more commands you have in the Docker file, the bigger the image is. Because every line in the Docker file will create a new layer in the repository with diff from the previous one. So it's like a stack. So you need to send all of them to the repository, and you need to pull all of them from the repository. And a pro tip, if you use the ID of the layer, you can connect, you can create an instance of the container on this point of the Docker file. So it's super easy to debug problems with like compilation or something. You have a lot of stuff that is happening, and you can create a container exactly in the point of the Docker file. So, example, we have a simple Docker file from Debian. We run apt-get update, and this creates second layer. And we install curl, and this creates third layer. The issue is that when we pull the stuff from the repository, it doesn't refresh it. It just gets the state of the push. So they are not refreshed. In this case, when layer 1 and layer 2 are not refreshed. So when we add Nginx to the third layer, it will use the Nginx version that apt has cached from the time that the image is created. This can be Monday or 6 months ago. So how to solve this issue? You need to compact your Docker files into as less as possible, as small as possible number of lines. By line, of course, we mean the keyword on the beginning of the line. So, because this is still one line, we run apt-get update, and if this is successful, we run install, go to the next line, curl, and Nginx. Then every time we add some new package to this line, like PHP or some extension, it will get the bare Jesse image, and then it will rerun the update every time. So this is super useful, and this is this will make your life much easier. Another lesson that we learned is we shouldn't do everything ourselves. So there is a hub.docker.com. This is like a public repository that Docker maintains that stores a lot of ready-to-use containers. For example, MySQL is stored there, and it has some neat features. For example, you can mount host directory to use as a data directory in MySQL. So you can move the data, you can switch the database instance and leave the files. You can add custom config files. So -v is a mount this file to as this file inside the container. You can specify as an environment variable MySQL root password, user password. You can automatically import database. If you have an output from MySQL dump, for example, and if you mount this directory with the MySQL dump as this directory inside the container, the init script from MySQL will take this file and run it after the database is created. So you can automatically import stuff there, like this. Sorry, this is Solr. You can also put scripts there, and it will list them alphabetically. So A, B, C, D, E, F, G, and it can be .SQL or .sh, and all of those scripts will run on the container during the container initialization part. So this is super useful for automatic database creation. The same goes for Solr. Anyone using Solr? Yeah. So you can mount the data dir the same way. You can run init, and yeah, this is the same way. So if you mount script Solr as this directory, it will also do the same thing as in case of the database, with the exception of the SQL files. So if you have .sh files there, it will list them in alphabetical order, and it will execute them before the Solr core, before I think it's just after the initialization, but before the core is ready. I have a missing word there. Same goes for PHP. So you can source the image, your Docker file, on official PHP Docker image file, and you can. They prepared some shortcut scripts. So if we require this extension, we just need to make sure that all the dependencies are installed before, and then this script will install the extension, will create an ini file, will put it in the specific directory. Same goes for extensions that needs compilation, like GD. You will have to prepare the environment with this directory there, but then the same way you can install the GD extension, for example. So this is super useful because you don't have to work on the base image and reuse the existing one. They have a lot of images, a lot of versions with FPM, without FPM, with Alpine Linux, for Apache, a lot of versions, and we use that as a base image for our code. You can also add custom configuration for the PHP. So as before, just mount this file into this directory, and it will just include it. For the logging, if you specify this as an output for the logs, then running this command, optionally with -F for just like tail, will display all the error logs from the application. You can do the same for example, for access logs or for FPM error log. Just use this or this descriptor or other one, the next one. Now, Vagrant. As I mentioned, Vagrant File is a Ruby script. I'm not a big fan of Ruby, but it's useful. For example, if you want to detect host IP, you know, every time we run it on different machines, the IP can change. Just run this, and you will have it as a variable. This is super useful. If there is no directory admin, just clone it from repository. So even the first time the developer runs the code, it's only Vagrant app. We automatically clone everything from the repositories using this check. Same goes for the Composer install. If there is no file, just install it after the code is there. Scripting means that we can use some advanced constructs like loops. So if we have 3 containers that are basically the same, we can define them as a loop and just use the variable in any way we want. We can link multiple containers. So we have an Nginx, and we want to link the containers with it. So define them, each link, add volume, because we all know that Nginx needs to see the file before, like a static file. So if our application has some JS, CSS, or anything, we need to have it inside the Nginx container, because to serve it, Nginx needs to see it. What about the Alpine Linux? So there are some containers that are prepared with this version of Linux. This is a special version, only for made for the containers, and it's like stripped down. It's few megabytes versus few hundred megabytes, but there are some issues with it. So in our case, we do use Solr and Cassandra, and those 2 extensions don't compile on Alpine Linux because it's used Musl instead of glibc. So if your application is simpler and you want to decrease the image size, you can use that. But for custom code like custom C that relies on some other libraries, that it might not work. So we do have some issues with Docker. It's not like everything is super and we all live happily ever after. So the Docker is quite a new tool. The first public release was just a few years ago. And since that date, there was 4 rewritten from scratch data file system drivers for Docker. 4. We all love this kind of bugs after 5 months. So they're moving fast and they are breaking stuff. So you need to be prepared that after you update the version of Docker on your staging machines, everything will stop working for 3 days. So do that with caution. Do that. Be prepared before you do that. Another thing, the link between containers, it's now deprecated. So it will be removed in future versions. Our environment is not yet ready. We didn't replace it with networking. They marked it as deprecated half a year ago, so probably soon it will be removed. It's supposed to be simpler because you create a network and you share the network between the containers, and it provides a better isolation between them. But it has some issues. For example, it will not set the environment variables. So we rely on them, and we will have to change our config style. It adds you the automatic name resolution, so you can use just a name as a name of the another machine, but we didn't migrate our code yet. There is another issue of maintaining the number of web networks. I read on the GitHub for Docker that after 1,000 networks on a single daemon, there are some issues with performance. So you will have to clean up the old networks. For example, if you create a network for a specific branch, then you will have to remove it after that. So it's another layer of things that you need to remember to do. And by default, the network, sorry, the last sentence. By default, the network traffic is not forwarded from inside the container, outside. You will have to adjust the host settings for the kernel. The link is there, but it's also in the documentation. Questions? Yes, potentially you can do that if you have, for example, Amazon and their Elastic Container Service. If they detect push of the image, they can restart all the instances for you. So if you prepare the image and do push, in the next few minutes they can restart everything for you. But it's a paid service. It's not like default feature of Docker. So potentially, yeah, you can use only that.
So, can I somehow use Ansible anywhere, or it's completely useless?
Yeah.
The answer is no, because Ansible have plugin for Docker, so it's different.
Yeah, so I don't use it, so I'm not that familiar. You will have to consult the manual. Or this guy, yeah.
How are you handling the file synchronization between Docker and on the daily basis for the developer? Because when it when it is changing the files, you need to push it to the Docker image, or
No, so when there's a new feature that requires change, the developer just includes this change into the feature branch. And on staging, when we do deploy to staging, it will fetch the Docker file from the feature branch, prepare the image, and it will run with the, for example, changed version of PHP or some new extension or different version of extension.
okay, so the developer on the daily basis is not working on the Docker?
Yeah, on the local machines there is a Docker there. So Docker itself detects the change. So if you do Docker run, it will detect the change. No, the Docker file. We do have a script for that. So they're running the if there is a change in the Docker file and they need to see it, they run the build script and it will create the image.
I'm not talking about the Docker file. I'm talking about the code for the application, for the admin or whatever.
So the code is mounted from the host system. So we point PHP Storm, for example, into the directory, and it's mounted inside the container. So you work on the code, press F5, and it's there. Yeah, it's shared volume. Any other questions? Yeah. Can you repeat, please? So I often see that people ask about it, but either our workstations are new enough or something, because we don't see that. So our web developers even have additional layer because they run VirtualBox with mounted folder from Windows, then in Linux, and then they mount it inside the container, and F5, and it works. So the PHP Storm is running on the host on Windows. So it has the fastest way access to the files. So this is okay, and then it just works in PHP. So I'm not sure what we do, what we are doing okay, or what everyone else is doing wrong. But we didn't have an issue. We do have SSDs for everyone, so this might be the latest one. 5.27, 5.1.27. I don't remember. We use pretty recent ones. Okay. So, no one reported it for me, and even I use it on Windows from time to time to check if they could potentially have an issue with something. So I didn't notice it. Yes. With what? So we started with Vagrant because it was before or just after release of Docker Compose, and we didn't have time to migrate it. And the stuff that are Ruby specific are loops and variables. From what I saw, the Docker Compose file is just a manifest file. It's not interpreted in any way. Yeah, but you would have to write it. Yeah, and Vagrant also manages VirtualBox for Windows. No, we're using the VirtualBox approach. Yeah, we haven't migrated it yet for the containers because the preferred way from Windows created update from that was on the slide is to use the Linux containers on Windows, but we didn't have time to migrate it yet because it requires time, and this works. Yeah. Well, not ever, because probably sometime in the future it will be broken by some vendor like Microsoft or someone else. Not to name anyone. Just an example. Okay, so thank you very much. I will have a second presentation about the tools, Vagrant and Think tomorrow, just before lunch on the in the big room. So if you want, please join me there.